Hi students, it's me again. I was just going to get a little bit of stuff started on chapter 7 and share sort of some high points with you on some of the things that I've seen students struggle with a little bit before. Something I want to throw out there as I'm getting started right now, please, and I say this for your sake, not for my sake, they're your grades, definitely consider doing the assigned readings here. Chapter 7 is a bear. I am only going to go through a handful of really important things. There's a lot more stuff in there. I will absolutely test you over that stuff. I assigned the chapter, you're going to read it, you can be tested over it. So make sure that you've looked at those chapters, okay? I am going to go over a few things with you, just some sort of foundational basics with the hope that that'll sort of help some of the things you're reading in the textbook stick. And if you have questions, absolutely come see me in my office hours, but I do want to make sure that you are doing some of this learning independently. This is a flex class that is absolutely expected of you. If you haven't read the book, that's on you, but your grades are also on you. So with that, I'm going to go ahead and jump over here into my PowerPoint and I'll show you a handful of things that are important. And I'm going to try to keep these short just because it's so much easier when a lecture is on video to not have to go for very long. So first of all, we're going to get into some physical geography in just a minute, but the big thing I want you to take home about chapter 7 is over half the world lives in chapter 7's territory. Okay, if you think about just generically human being, the odds are statistically, if you come from outer space and you meet a human being, they are from Asia. China has 1.4 billion people. India has 1.4 billion people. Most of the top 10 largest populations in the world are in Asia. So I want you to kind of get a hold of that because it's very easy to be dismissive of that from halfway around the globe. So I've got here population pyramids for China and for India from 2016. I'm going to show you 2019 ones in a second, but there are a couple of things I wanted to just quickly remind you of. First of all, China looks like it's in a traditional stage for post-industrial population pyramid structure. What happened with China actually is a little bit more complicated than that. In the late 1970s, China imposed its one-child policy. And the thing is, Chinese people are not stupid. Chinese people knew that a one-child policy was going to shrink the population because they were not hitting replacement rate. But that was sort of the idea. They wanted to get a stranglehold on population growth. And just about 2014, 2015, China actually they modified the one-child policy. They want to say they banned it or they repealed it. It's not exactly true. They went to a two-child policy. Same policy, same expectations, but 2 kids instead of 1. And one of the things that happened that's really interesting is that happened in 2014, and we really didn't see that any immediate response in the birth rate. It turns out if you spend 40 years telling a society that the ideal family is 2 parents and 1 child, that's going to kind of stick after a generation. And when the entire generation who's really raising families right now was raised in a one-child sort of policy structure, they're not necessarily eager either to explore beyond that. So it's become an interesting thing for China. India over here, you'll notice has been sort of, they were stage 2 30 years ago. Absolutely no arguing that. If you ignore the bottom 30 years of this population pyramid, it was a stage 2. But they dropped very quickly into something that's looking more like a stage 3 or even a modest stage 4. India did not pass a one-child policy. India's birth rates have done this more sort of organically as a response to other developments in India. So with that said, basically China's population is growing more slowly than India's population. So while India at present is smaller than China, India is growing faster and is likely to outstrip China's population at some point. The other thing I wanted to sort of remind you of while we're here is that you can see selective female infanticide represented on both of these age structure diagrams. And you remember when you're looking for selective female infanticide, what you are looking for is basic symmetry in the structure and in the shape of a population pyramid, but with the male side slightly exaggerated in size above the female side. And that's exactly what we see here. So here are 2019 population pyramid. So it was 2014, 5 years before this population pyramid was created, that that China modified its one-child policy and said, okay, you can have a second child if you want to. But lo and behold, look at the bottom 5 years of this pyramid, that bottom rung. And what you see is actually the population has continued to shrink. There are fewer children under 5 than there are children between 5 and 10. So that change in the one-child policy did not touch birth rates. It turns out changing policy is different than changing minds. In India, in the meantime, their last 10 years, the two 5-year brackets that make up their bottom 10 years are identical. 4.7% male, 4.3% female for both generations. And again, notice that male and female side are symmetrical, with the female side slightly shrunken, the male side slightly exaggerated. That's where you can find a cultural preference for females. And you see the same thing over here in China, of course, 3.1% male, 2.7% female, 3.2% male, 2.7% female, 3% male, 2.6% female. So keep an eye out for that. When we see those really drastically asymmetrical population pyramids, like I showed you for Qatar and United Arab Emirates, there we're looking at a surplus of working aged adults disproportionately male. That's a migration pattern. This is not a migration pattern. This is a completely different looking kind of thing. So keep an eye on that ball and look at these population numbers, by the way. I'm going to go backwards again so you can see these 1.382, 1.386 by 2019. 1.398, 1.373. So India's population is growing just a little bit faster. So this is the region that we're looking at. I want you to look at your book and develop some appreciation for the 3 basic subregions that Asia is broken up into. I'm not going to go into that in this lecture because I think your book actually does a really good job. And I don't see any reason to waste time when you're having to sit through a video. Your book does fine. But there are 3 basic subregions. If I were writing this textbook, honestly, I would give each of those subregions their own chapter. That's how drastically different they are. So look at the physical geography for just a minute here, and that'll give you sort of an appreciation for that. Here we have this massive sort of high plains Gobi Desert and Tibetan Plateau region. All of this is high elevation, low rainfall. They're subject to the effects of continentality, so their precipitation rates are actually very low. Their altitude can be a little bit high, but they tend to be where you find lower populations, because this is also where you find a landscape that is a little bit less hospitable to urbanization. You will find, though, over here in the eastern third of China, this elegant multi-river system. Now that river system is fed by snowmelt that comes from the Tibetan Plateau and from the Himalayan mountain range. That's actually going to be important when we get to the conflicts between China and India over control of the Himalayas. So put that kind of in your back pocket for now. It is going to be important. But that snowmelt feeds river systems that support literally billions of people. There's billions with a B. We don't even have that many people in all the United States. And so this is kind of important. So that East Asian region is actually kind of its own beast a little bit. And then we've got the South Asian region, where actually we saw a massive migration of people from Central Europe down into India. And they brought a little bit of a different cultural system than we see in China, Mongolia, and Japan. So this has imparted a really different series of cultural practices onto Afghanistan, Pakistan, India. And in addition to that, we see the Mughal Empire also make its way down into especially northern India, and they bring Islam with them. So in Pakistan and in Afghanistan, that has become the dominant religious practice. When you get down into Southeast Asia, into Thailand, Cambodia, Vietnam, it's a little bit of a different frame. We see the influence of the Aryan migration sort of start to fade out a little bit. We see a little bit more East Asian culture sort of represented there. But then we've got this vast arc down here, this crescent of island nations. And these island nations are, again, their own beasts. So Indonesia has literally hundreds of islands. Philippines has hundreds of islands. And so these island nations often are made up of lots of smaller units of land separated by water, but united under a single national identity. And the island nations tend to be, again, physically, geographically, culturally, geographically, they just are their own different spaces. So that's the 3 sort of ways that they would be divided in a different kind of environments. We're going to look really quickly at what's going on in terms of chapter 2 physical geography here, and specifically with the formation of the Himalayan mountain range. This region was actually one of the more controversial but important regions that Alfred Wegener looked at when he was forming his theory of continental drift that we talked about just a few weeks ago. So you remember Wegener proposed that, in fact, the land that is on the earth might be moving around, but moving around slowly enough that it's not necessarily perceptible to human experience. And he made geological studies to try to validate that claim. And one of the more controversial things he said was that he thought India was not in fact a part of the Eurasian landmass, but was what he called a subcontinent. And so you've probably heard people say that today. They call it the Indian subcontinent. Well, what was going on, Wegener proposed, was that India had actually been a separate landmass at one time, down here, represented here in this graphic, and that over vast expanses of time, India had shifted up into the Eurasian landmass. And when it pushed into the Eurasian landmass, where they came together, we see this massive tectonic upswelling of rock and land, and that effectively is going to become what forms the Himalayan mountain range, which is the highest and most rugged mountain range in the world. So how would you support this? This comes back to what I asked you before. Very little that we know about what happens beneath the topsoil has been validated through direct observation, and instead we come to it by theoretical observation. And so what we see here is India is in fact geologically very distinct from the rest of the Eurasian landmass. The composition of its rock and its mineral possessions are actually very different than the rest of the Eurasian landmass, suggesting that Wegener could actually have been onto something. And then of course that other body of evidence would be these massive Himalayan mountains. So the Himalayan mountain range itself, it's the highest mountain range in the world. This particular picture is of Mount Everest, which is the highest mountain in the world. And I know that hurts people's feelings sometimes. The United States has some lovely mountains. I don't mean to disparage or insult them in any way, but all of the highest mountains in the world are actually in the Himalayan mountain range. The next highest mountains are in the Andes mountain range. The Rockies, they come to play, but not for first. They're really just here for the trophy. This particular mountain range is a significant dividing line that stretches all the way from Pakistan across India through Nepal and Bhutan and into China. And the cultures that it houses are actually fairly distinct. Parts of Bhutan can actually have a subtropical climate, and of course parts of Nepal are habitually continental and cold. And you remember again, back in chapter 2, when we talked about physical geography, mountains have an important relationship to rainfall. So remember when we talked about the orographic effect, what we saw was that where you find a mountain range separating a land mass, like over here at the Tibetan Plateau, from a large water supply, like say the Indian Ocean, you tend to find a wet side and you tend to find a dry side of that mountain range, because as an air mass that is laden with moisture rises up in altitude, it is going to cool. As it cools, that moisture condenses and it comes down as rainfall. So we're going to look at the impact that actually has on this region. So, and before I do that though, I'll come back, and you remember we looked at Wegener over here. And you may remember this from the first week of classes. This is the Pacific Ring of Fire. The region that we are looking at here is heavily defined by tectonic activity, and especially in the insular areas. So we tend to see some support for Wegener's theory, and the Himalayan mountain range itself is heavily influenced by tectonic activity with frequent earthquakes in particular. So we're going to go to South Asia for just a minute. There's a physical geographic trait I want to make sure that you kind of become a little bit familiar with, and that is the monsoons. The monsoons are not complicated, but they confuse people, and so I want to make sure that you get a hold of what's actually going on here. So the first thing I'm going to call your attention to is right over here where I'm kind of moving my mouse around on the screen. At 10 degrees north latitude, we're sitting really close to the equator. And when you're that close to the equator, you remember you don't have a quadri-seasonal system where you have a hot summer and a cold winter. Instead, you have basically a wet season and a dry season. You may not see a lot of variability in temperatures that close to the equator, just variabilities in other factors. So what you see in India is no exception to that. And India's weather patterns are largely defined by two really basic laws of physics. The first is that hot air rises, and the second is that water has a high heat capacity. When you take those two concepts and you put them together, you're going to get the monsoons. So what happens over here in India, we have this massive Deccan Plateau, and surrounding India on three sides, we have the Indian Ocean. And we're going to deal with the difference between oceans and seas in the next chapter, so I'll save that for a surprise, but suffice it to say for now that the Arabian Sea is part of the Indian Ocean, and so is the Bay of Bengal. So we've got this massive chunk of land that sits at high elevation, surrounded on 3 sides by water. So water has a high heat capacity. What that means is it takes a lot of energy input to change its temperature. And so once water gets hot, it stays hot for a long time, but it takes a lot of energy input to get water hot. So it's not necessarily going to heat up as quickly as the other things around it. So this comes in handy sometimes, right? This is why we use hot water bottles instead of, other things, because water will retain that heat for a really long time once it is warmed up. So during the summer is the easiest place to demonstrate this first. So over here, we see the sun high in the sky, vast amounts of solar energy beating down on the Deccan Plateau and also on the Indian Ocean. The Indian Ocean does not heat up as quickly. It absorbs more heat without really changing its temperature that much. The Deccan Plateau, on the other hand, is going to heat up really quickly. So now we have the land that's much hotter than the water around it. So when that happens, again, hot air rises, right? So the air above the land is going to become superheated by all of this heat radiating off of the Deccan Plateau, and it is going to rise. And when it rises, that's going to create a vacuum, all right? So when some air moves, other air moves in to fill the space that it evacuated, right? So we get an upsweeping and an insweeping of air. And where does that air come from? Well, from the Indian Ocean, mostly. And so we're seeing air sucked in from above the Indian Ocean. This is moisture-laden air. And so when we get moist air sweeping into a vacuum above the Deccan Plateau, that moisture-laden air, of course, is going to heat. Because it heats, it's going to rise. When it rises, again, laws of physics, such a beautiful thing, it's going to cool as it goes up and up and up in altitude. It cools. When it cools, the water condenses and it falls as rain. Not just any rain either. This is torrential, consistent long-term rainfall. It's not quite like a thunderstorm in the Midwest because you don't necessarily see a lot of thunder and lightning, but you just see torrential showers. And a shower almost sounds like transitory, but I mean like just standing in the shower with the water on and it just keeps coming because the Indian Ocean is continually resupplying this super warm air. So in the summer, we see these monsoons last for several weeks. And in that season, we see lots of flooding. But this is not necessarily the worst thing because this little piece of land that makes up the entire country of India is about 2/3 of the size of the United States. And it supports 1.4 billion people, which is about 4 times our population. So that water is actually essential to India's agricultural strategies. So we have a drastic rainy season that we call the summer monsoon. The winter monsoon, again, the rules are exactly the same. Oh, and by the way, as those air masses approach the Himalayas, again, they're going to rise and we're going to see lots of snowfall on the Himalayas. And because they're at high altitude, a lot of snowfall just stays. People argue over how tall Mount Everest actually is because people who say you should just measure the rock and not the snow, say it's 29,017 feet. And people who say, no, the snow counts, you should measure it too because it doesn't melt off, say it's 29,029 feet. There are 12 feet of snowfall just sitting there on top of the Himalayas. So anyway, I say all that to say in the winter, we're going to see this pattern invert itself. So now you remember we've had all summer for the ocean to collect and retain heat, and the Indian Ocean has actually become quite warm. And the Deccan Plateau, while it was very hot, it is going to cool off faster than the Indian Ocean does. So now we've got vast amounts of temperature difference between the Deccan Plateau and the Indian Ocean. So now where is the air rising the fastest? It's over the Indian Ocean. And that also creates a vacuum and it pulls air from over the Deccan Plateau and over India out to sea. The air that's going to replace that is going to be mostly from inland, from Pakistan and China. It's going to come from over the Himalayan mountains. So as a result, there's no moisture left in it. So you get hot, dry wind in the winter monsoon. It is not cold, dry wind. It really, we're talking about 20 degrees north latitude. It's like Florida. So we don't necessarily see it get extremely cold unless you're at altitude, but you do actually get these continuous dry winds for, again, periods of several weeks. When you get a relative balance between the temperatures of the Indian Ocean and the Deccan Plateau, you don't see these drastic seasonal patterns, but this defines every single year for India. So what does this mean for the people there? The most important thing is that agriculturally, you cannot grow the same crops in these two seasons because the climatic conditions are so drastically different from each other. And so most people in India who practice subsistence agriculture, and it's a shocking number of people for a country of 1.4 billion, over 2/3 of the population are subsistence agriculturalists, villagers, things like that. That population tends to grow different crops at different times of year in order to maintain a degree of diversity in their diet. So they might grow lentils, they might grow millet, they might grow rice or another grain crop, but they're going to tend to have their separate winter and summer crops. And the tendency is going to be to try to retain as much of that water as they can from the flood season to make sure that they can care for their crops over the incredibly dry, drought-like season. So these monsoons are really basic physical geographic pattern, but it's something I'm going to want you to be able to explain back to me. So for those of you who are actually watching the video, take note, take note. I usually ask about this on the final. So there you go. That's free with the lecture. So this is some of the impact. This is actually a couple of weeks after the summer monsoon, which summer monsoon means torrential rainfall, lots of flooding. And what I really want you to get out of this is you can see this road here. After a couple of weeks of drainage and drying off, these people are able to get across the road. But one of the things that the monsoons do to India that makes it an extremely interesting situation for things like development and infrastructure is that the monsoons cut off exchange between different regions of India for long periods of time. There's not a road system or a railroad system that is unimpacted by these weeks of torrential rainfall and the subsequent flooding. And so what that means is it's very difficult to crisscross India with a network of any kind of transportation system really that would allow continuous exchange. So, you know, when we talked about the relationship between economic sectors, the primary sector, the secondary sector, the tertiary sector, we talked about the relationship between cores and peripheries and how they have to have a fairly fluid exchange of raw materials, labor, and finished goods in order for them to function effectively. India is in a position where it is largely primary sector right now, and it is unable to transition to the secondary sector because of these physical impediments to exchange. And yet, most of us have talked to somebody in India in the last year or so, because when you call tech support, that's where the calls go. Why does this happen? A handful of complicated reasons, but basically India is making a concerted effort to jump over the secondary sector and to land in the tertiary sector. Because remember, the tertiary sector is information, services, and luxury goods. If it's not possible for India to really function effectively in the secondary sector because of their physical geographic limitations, jumping over the secondary sector and landing in the tertiary sector by providing services like call centers is a potential way to at least explore economic development. And so there are a handful of things that make India ideal for that kind of service. First of all, that English is spoken as a first language there. And I know that the accent is fairly pronounced to the region, but people with an Indian accent don't typically have that accent because they don't speak English as a first language, but rather they speak Indian English as a first language. So the fact that they have English as a first language makes it very simple to hire people to provide services to English speakers from the West. And then the fact that labor is actually very inexpensive, because with 1.4 billion people and no secondary economic sector to speak of, there aren't a lot of jobs. And when supply is high and demand is low, prices are low. And the price for labor in India right now is very affordable. And there are other industries there, but they tend mostly to be coastal, where goods are imported and turned into finished goods and then exported again. The idea that India could become self-supporting with its own periphery for its own core is a nice one, but it may not be practical for a really long time because of this impediment to infrastructure that we see. Nonetheless, lives depend on these monsoons. This is the Western Ghat. So if you stand in like the northern half of, well, like the northern third even of the Deccan Plateau, and you look out to the north, this is what you're gonna see, this Western Ghat. And actually look out, look at the shapes of these mountain ranges, because I'm going to show you something in a second that's important. This photograph was actually taken on May 18th. This is a photograph of the same mountains taken on August 18th. 3 months difference in this dry, parched, desert-like landscape and this lush green, well-watered one. So we wouldn't necessarily even try to associate these two spaces in our mind with the same climate system. The drastic difference, desert conditions and flood conditions in the same space over and over again, cyclically year after year, makes India and really monsoon Asia more broadly a very unique physical geographic space. And the population is highly dependent on this pattern for their own survival. So let me see what else I've got for you over here in physical geography before I shift on. Oh yes, this is the other thing that deserves a little bit of conversation. So first of all, this photograph is in Bangladesh, but Bangladesh experiences the same kind of monsoon seasonal flooding that we talked about elsewhere. And what happened basically is the water saturated down into the mountainside. The mountainside became destabilized. It basically got muddy. And then the mountainside is just going to collapse down and the train tracks were swept down with it. And this particular accident looks really, really drastic. There were a couple of fatalities, but most of the people on this train actually survived this incident and were able to eventually be rescued or crawl out themselves to safety. But this is something that you fully expect to see every monsoon flood season, that this disruption to the landscape is just a part of the cost of doing business in India, in the same way that we sort of think of tornadoes as terrifying and destructive, but inevitable where we live. So this kind of disruption, again, just comes back to that infrastructural problem. The train systems cannot run consistently through the monsoon season, and that has created some complexities to building an integrated economic system in India. So moving right along from that, I actually think, yeah, go ahead and look at this one feature of agricultural adaptations, and then I'll cut this video off and I'll create a second one for you to talk about a couple of other things. So we tend to think of a tropical landscape especially as being a particularly lush and fertile landscape, but tropical rainforests, such as you find in that insular part, the island part of Southeast Asia, are actually not that fertile, because this interesting thing happens when you get very hot temperatures, very high temperatures with very high humidity. Organic matter will actually break down too fast for the nutrients to leach down into the soil. And especially when you couple that with torrential monsoon rains that tend to create a lot of washing away of those nutrients, what happens is actually the soil doesn't ever reap the benefit of sort of the shedding of its own foliage and things like that. So that combination of high temperatures and heavy rains means that they really don't get a good, rich, fertile soil like you would expect. Instead, the plants that thrive in this area are very often the ones that can draw at least a portion of their nutrients from the air instead of from the soil, or from water instead of the soil. And typically, if you should slash and burn a swath of, say, a tropical rainforest, you're only going to be able to get a few poor harvests, and then you're just gonna have to leave that land fallow and go slash and burn a different piece instead. In spite of the fact that it's not extremely efficient, that is what a lot of people do, especially in Southeast Asia, where people practice subsistence farming. They're still literally growing the things that go on their table. They really aren't participating in the get a job mentality, because there's nowhere to get a job, because there are no restaurants or grocery stores or anywhere else to really get a job per se. Instead, they live more directly in contact with the resources that they're going to consume. So what that means is basically you cut down a piece of the forest, you plant your crops, you grow your crops for a couple of years, and then you're actually going to abandon that spot and let it go fallow, and it's going to return back to forest again, and it's going to recover. You're going to slash and burn a different piece of the forest, and you're going to grow new crops there again. And the funny thing is, when this is done on a very large scale, this is going to be highly destructive of a tropical rainforest environment. But when this is done on a micro scale, with a family clearing a half acre to an acre at a time, this is actually not as destructive as you would think, because more of the forest is in recovery at any given point in time than is under cultivation. But really, it's not something that people do because they want to, so much as because the landscape just won't support more. They get one or two decent-ish harvests out of a slash and burn space with these infertile soils, and then they've got to go somewhere else and try again. So where you don't see slash and burn agriculture, you have what we call intensive subsistence agriculture. And this is a highly unusual framework. Normally when you see very intensive agriculture, it's being done for commercial purposes, where people have been able to invest a little bit of time and money and education and equipment into sort of squeezing the last bits of productivity out of a given space. They're using commercial fertilizers, they're using high yield seeds and things like that. And that combination of resources allows them to sort of get a little bit higher yield per acre than maybe you or I would get. So intensive subsistence agriculture is when a group, like possibly a family, but more often a small community like a village, is going to use a small piece of land over and over and over again to produce their living. In the places where this is executed to a high level of efficiency, a square mile of land can feed up to 500 people. That's done in parts of Bali, parts of Java, which is part of Indonesia, and places like that. So a very large population can actually be fed without necessarily industrializing. Not everywhere in the world can do that, but Southeast Asia can. So the way that they do this is through wet rice cultivation. And wet rice just refers to the practice of flooding the rice fields with water and running water high up the stalk of the plant in order to improve harvest. And there's this weird idea in the United States that the rice needs to grow in water in order to grow. And that's actually not exactly true. Rice is actually pretty versatile in terms of its ability to survive in even sort of drought-like conditions. But what rice is not super good at is fighting off pests and competing with other species. So if you try to put some rice in your front yard, there's a good chance that the grass in the front yard or the dandelions or whatever you have are going to sort of choke the rice out. But very few pests or invasive plant species can live underwater, and rice can. Rice draws most of its nutrients from the air. It can continue to draw its nutrients from the soil, or what nutrients it can get from the soil. But when you flood a rice paddy, you actually eliminate a lot of the bug pests that would try to eat the crop, and you eliminate the weeds that would compete with the rice for nutrients. And so flooding the rice paddy isn't exactly done because it's good for the rice so much as it's done because it's bad for the stuff that would destroy the rice. So sort of indirectly beneficial. So wet rice cultivation, where it's practiced in the warmer parts of insular and Southeast Asia, rice is not necessarily as widely respected in like the northern and colder plateau portions of Asia. But where rice cultivation is practiced, typically a community can get 2 or 3 really good crops per year. And so 3 crops of rice a year is going to sustain a population with a comparatively small amount of land, but a fairly high level of effort over a long period of time. So this is mostly practiced traditionally in lowland floodplains, or at least was for a long time. But as populations started to grow, they started to do this very interesting thing where they would start to build terraces, where they would basically cut little tiny narrow strips of fields, more or less, a flat space into the sides of mountains so that they could expand their growing potential. Because if you've ever just tried to, plant some squash up the side of a mountain, you may find that the landscape really doesn't allow for it or support it that much. So more on that in just a second. We'll go ahead and hit plantation agriculture really quickly. The big thing I want you to know about plantation agriculture is that it's universally oriented to the commercial market. If you're not selling on the commercial market, you're not a plantation. And the plantation crop that is the single most common one in Southeast Asia right now is palm oil. And the thing about palm oil is it comes from oil palms that are already native to the region, or at least are adapted to the region. So you can slash and burn the natural rainforest, you can plant oil palms, and they will actually survive and function in even these fairly poor soil conditions. So vast parts of Malaysia, vast parts of Indonesia, vast parts of other island or Southeast Asian and insular Southeast Asian regions have been given over to palm oil production specifically. Palm oil is in almost everything. There are times I've sent students to go through their backpacks or something like that and just start reading the backs of labels to find what snacks and what cosmetics and things like that actually contain it. Palm oil is in lots and lots of stuff. It doesn't go rancid easily. It doesn't have any flavor or smell to speak of, so it doesn't disrupt any kind of flavor that you're trying to create. And so palm oil is cheap and it's non-disruptive to other objectives of flavor or smell. And so because of this, it's actually really, really popular on the commercial market, and lots of commercial food and cosmetics producers use it. So in Southeast Asia, that has led to some unfortunate consequences. The island of Java has been given over so substantially to palm oil production that the Java rhino and other species that used to live there have actually gone extinct. And so this is an imminent threat to indigenous wildlife and to indigenous ecosystems, but it's also done for basically the same reasons that we work at McDonald's, because it benefits people's financial outlook in the short term. So I'm going to come back just really quickly to this wet rice cultivation, because I had a few pictures to show you of how that is done. You can read more about palm oil production in your textbook. The big thing I wanted you to sort of be aware of is that's sort of the framework of the types of land use we see most frequently in the Asian region. We see subsistence agriculture, we see wet rice agriculture, and we see some plantation production. So this lady is in a flooded rice paddy here. This is a traditional hat that she's wearing. It basically gives her a little bit of protection from the sun. And these are rice plants here. It looks like she's probably cut those off with a knife. It may be hanging over here on the other side of her outfit or something like that. This is in Banway. These are the rice terraces in the Philippines. They are a recognized UNESCO World Heritage Site today, but these are the types of terraces that you would use to grow rice once your population outgrew the flat land at the bottom of the mountain range. Either you continue to feed your population through innovation, or your population dies out. You remember, it's back to that Thomas Malthus versus technocentrism worldview. If you don't innovate, then you reach a Malthusian crisis. But when you innovate, you forestall that Malthusian crisis. And so that's what's actually gone on here. This is incredible innovation. And the way that this system works actually is the tendency is to use pumps or manpower or other innovations to bring the water to the top of the mountain, and then to use a series of flooding strategies to work the water systematically down these terraces. So the most important thing to think about is you don't want to have to flood this terrace at the same time that you have to flood this terrace. You want to strategically organize your planting behaviors so that you plant this first so that you flood it first. And then you plant this next so you flood it next. That way you can run the water strategically down through this irrigation system over time. So we're going to talk about the cultural implications of that in a few minutes, but in case you should think that these rice terraces were somehow isolated, this is a more distant view of the Banway rice terraces. And one of the interesting things about these is actually, since they became a UNESCO World Heritage Site, tourists have been making their way to Philippines to see these incredible rice terraces. Young people have very much left the rice production industry, and they stopped sort of working on and maintaining and planting the terraces, and have gone to work in hotels and as tour guides and as drivers and in restaurants oriented to the tourist industry instead. And as a result, the rice terraces are actually falling into disrepair. It's almost as if they've become a victim of their own incredible fame. So I'm going to probably leave it at that for the moment. We're going to come back and talk about some of the cultural implications of this type of land engagement in the next video, but I like to keep these short since we're trying to operate like sort of asynchronously and not exactly interpersonally. As always, feel free to email me with questions, catch me in the office with questions, ask questions in class. I'm happy to help you guys any way I can. I just want to make sure that we kind of stay caught up a little bit. So with that, have a fantastic, fantastic day, and keep an eye on these concepts as you're looking at the study guide for the final exam.